Welcome to our new unit on sequences and series. So many events produce data that form patterns, and these patterns are called sequences. There are two main types of sequences: arithmetic sequences and geometric sequences. In this video, we're going to focus on arithmetic sequences. So in an arithmetic sequence, the difference between the constant consecutive terms is constant. And that constant value is called the common difference, or labeled as D. So here's an example of an arithmetic sequence: 2, 4, 6, 8, 10. The first term of the sequence is called T1 for term 1, and this is 2. And the second term of the sequence is T2, term 2, which is actually 4. And the common difference is found by subtracting the first term from the second term. And then also, you can also subtract the second term from the third term, and so on. So, for example, to find D, you would take the second term minus the first term, which is 2. So that means D is 2. You could have also used another one. For example, 6 minus 4. So the third term minus the second term, of course, you're going to get 2 again. So that is your common difference. The dots at the end of the sequence indicate that the sequence continues forever, which is called an infinite sequence. Arithmetic sequences could either be increasing or decreasing. So here's an example of an increasing sequence where D is positive. So if we want to find D, it would be 3/4 minus a half, which is a quarter. So D is a quarter. And this means that this is an increasing sequence because D is positive. Now here's an example of a decreasing sequence where D is negative. So we look for the difference between 5 and -1. -1 minus 5 is -6. So our D is -6. We're going to go down by 6 from the previous term. So the formula for the general term of a sequence, let's consider 10, 16, 22, and 28. So if we look at T2 is 16 and T1 is 10. It looks like our D is 6. And then if we look at T3 and T2, 22 minus 16 is going to give us 6 again. So D is for sure 6. If I want to express T2, which is 16, using the first term, which is 10, and D, it would have been the first term, T1, plus D. Okay, and if I want to, again, do the same sort of thing, but for T3, I would use 10. This would be the second term, but I need another 6 in order to get to 22, or in other words, 6 times 2. So the formula looks like this: T1 plus 2D. And then lastly, this would be 10 plus D, which is 6, but then times it by 3 to get 28. So this would be T1 plus 3D. So if we look at our pattern for our general sequence, we're always going to have the very first term, T1, in there, and adding a multiple of D afterwards, depending on the number of term. So the general term of an arithmetic sequence is Tn, which is the general term, or the nth term, is equal to T1 plus n minus 1 times D. This is an equivalent version of it. All we did is switch the place of D and n minus 1. So n is the number of terms, D is your common difference. So let's apply this general term of an arithmetic sequence to actual examples. We're going to start off by writing down the first 6 terms of any increasing arithmetic sequence. So this could just be any arithmetic sequence. There's infinitely many. I'm just going to start with maybe 1 as my term 1, and I'll just go up from 2 from there. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. There's 6 terms right there. So this is an increasing arithmetic sequence because my D is positive. In this case, it's positive 2. Now let's look at a decreasing arithmetic sequence. Again, there's infinitely many out there. I'm just going to start off by maybe 10. And I know I have to go down because it's increasing. Let's just say I'm going to pick D is negative 3. So 10 minus 3 is 7, 7 minus 3 is 4, 4 minus 3 is 1, 1 minus 3 is negative 2, and negative 2 minus 3 is negative 5. And this is an example of a decreasing arithmetic sequence. Moving on to the next example, for the sequence 3, 10, 17, and 24, we want to determine T15. So I'm going to write down our formula to find the nth term of a arithmetic sequence. So if we're looking for T15, that means n is 15. T1 is the very first term in our sequence, and that's 3. N is 15 because that was our n here. And then D we need to find, which is not that hard. So if we compare these two, 10 minus 3 is 7. So D must be 7. We can check the next one just to make sure. 17 minus 10 is also 7, so D is for sure 7. Now we're going to simplify this, and we're going to be able to find the 15th term. So that's 3 plus 14 times 7. 14 times 7 plus 3 is 101. So that is our 15th term in the sequence. Next type of question, what term in the sequence has a value of 220? This means T to some n is 220. Some nth term is 220 in the sequence. We want to find what n is. So again, I'm going to write down our equation to find the nth term in the arithmetic sequence. In this case, I know what Tn is 220. We know what T1 is, that's 3, that's the first term. I don't know what n is, we're going to leave that alone. And we know that D is 7. So we're going to simplify this. I'm going to move the 3D to the other side, or in other words, subtract both sides by 3. So that's 217 then. And then I'm going to distribute the 7, so that's 7n minus 7 here. Now I'm going to add 7 on both sides, and then divide both sides by 7. So n is 32. This means that in order to get 220 as a term, it's going to be the 32nd term of our sequence. Let's do a few more examples. Two terms in the arithmetic sequence are T4 is equal to negative 4, and the 7th term is 23. We want to find what T1 is. So this is a little different. We have to work backwards in this scenario. We're going to treat T4 as T1 for now, just so that we can find what the pattern is and find what D is. So if that's the case, I'm going to write it out like negative 4 is going to be my first term. And then we're going to have another term, another term. So that's T4, T5, T6, T7 is 23. But instead of labeling as T4, T5, T6, T7, if I'm treating T4 as T1, that means this will be my first term and this will be my fourth term. And the reason I want to do that is we can use this as T1 and T4 for now, so we can find D. So we're going to use Tn equals T1 plus n minus 1 times D to find D. So my Tn in this case, I'm going to use it as T4, which is 23. And my first term I'm going to use as -4. My n in this case is going to be 4 because T4 is 23. And then I'll simplify this to find d. So we have 4 minus 1, so that's 3d then. And then I'm going to add 4 on both sides, which is 27. And then divide both sides by 3, so d is 9. 27 divided by 3 is 9. Okay, now we're going to find the real T1. And we're going to use the same formula for that. So Tn, we can use either -4 or 23, it really doesn't matter. So I'm just going to use -4. We leave T1 because we don't know what that is. And this was our fourth term in our real arithmetic sequence. And we just found d, which is 9. Now we're going to simplify. So 4 minus 1 is 3, and then times 9. And that would be 27. Then subtract both sides by 27. T1 then is -31. One more question. The comet appears every 9 years and was last seen in 2005. Determine whether the comet will appear in 3085. So it was last seen in 2005. I'm going to call this T1 as the first term because that is kind of our baseline of the year. This would be Tn because that's kind of like the final time whether a comet would appear or not. It occurs every 9 years, so this would be our d. Because after 2005, that means the next time the comet's going to show up would be 2005 plus 9, which is 2014. And then what we're looking for is n. The reason why we're looking for n, because if there is a whole number for n, that means for sure that this comet is going to appear in 3085. If we get a decimal number for n, we can't have an nth term be a decimal or fraction. It doesn't make sense because this indicates the term numbers, so term 1, term 2. It doesn't make sense to have a term 2.5. So we're going to find n. And if it's a whole number, then we're good. The comet will appear in 3085. And if we get a decimal number for n, then the comet won't appear in 3085. So let's fill this in. So Tn is 3085. T1 is 2005. We're trying to find n, and d is 9. So I'm going to subtract both sides by 2005, and we're going to get 1080 on one side. I can divide both sides by 9. Then I'm going to get 120. And then lastly, add 1 on both sides. We're going to get 121 is equal to n. So this is a whole number. So yes, the comet will appear in 3085.